In this video, I'm going to show you how to find the x-intercepts of a parabola based on its equation. So this parabola right here has a graph that looks somewhat like this, and we want to find the x-intercepts, which are right here and right there. The trick to finding these intercepts based on the equation here is that we set the equation equal to 0, because at the x-intercepts, the y-coordinate is 0. The x-intercepts are something, comma, 0, and something, comma, 0. So let's do that. Let's say 0 equals x squared minus x minus 2. Now we just have to solve this equation. We can do that by factoring. This factors to x plus 1 times x minus 2. And then we see that the solutions here are negative 1 and 2. So then this x-intercept is in the negative side, so that's negative 1. That intercept is in the positive side, so that's 2. There we have it, the x-intercepts. Here's another example. Let's find the x-intercepts of this parabola. How we do that is we set the y equal to 0 and then solve the resulting quadratic equation. So this one doesn't factor too nicely, so let's just use the quadratic formula. So x equals negative of negative 2, so positive 2, plus or minus square root of negative 2 squared is 4, minus 4 times 3 times negative 3, all over 2 times 3, all over 6. So then x equals 2 plus or minus, well, this part comes out to positive 36, and then plus 4, that's root 40 over 6. So x equals 2 plus or minus, this is root 4 times root 10, so 2 times root 10 over 6. So x equals 1 plus or minus root 10 over 3. So those are the x-intercepts. We've got the points are 1 minus root 10 over 3, comma 0, and 1 plus root 10 over 3, comma 0. All done. Here is another example. So our approach is the same. We're going to set the equation equal to 0 to find the x-intercept. And this doesn't factor nice, so let's use the quadratic equation. So x equals negative 1 plus or minus root of 1 minus 4 times 1 times 4 is 16, all over 2 times 1 is 2. So x equals negative 1 plus or minus root of negative 15 over 2. But there's a negative in this root, so that means there are actually no solutions. As a result, there are no x-intercepts. Here's a little bit of a different example. So now we've got a parabola, we know its intercepts, and we want to use the intercepts to find the coefficients in the equation for the parabola. So how we do this is we set up y equals, and then we need the factors of the parabola based on the x-intercepts. So this negative 5 as an intercept, that corresponds to a factor of x plus 5, because the solution of x plus 5 equals 0 comes out to negative 5. And then this intercept of 3, 0, that corresponds to a factor of x minus 3. So now we can just multiply out the factors. So y equals x squared 5 minus 3, so plus 2x, then minus 15, and then 2 goes to b, and minus 15 goes to c. And there we have it. There's our solution. This example is pretty similar to the previous one, but because there's a negative 3 in front of here, there's going to be a little twist thrown in. Don't worry about it just yet, but let's get the factors first. So y equals, this is the first x-intercept, and the factor corresponding to the x-intercept of -1 is x plus 1, and then the second x-intercept is that 4, so x minus 4. And let's go ahead and multiply that out. Y equals x squared, 1 minus 4 minus 3x, and then minus 4. Now, the only problem here is that there's a -3 here, and there's not a -3 here. But that's okay, because we can just multiply everything by -3, and then we'll get that -3 coefficient on the x squared. So -3x squared plus 9x plus 12. So now b is 9, and c is 12. That's our solution. In the future, we'll also learn a quick method for telling how many x-intercepts a parabola has, just based on the coefficients of its equation.